Okay, so let's create a data model for us being able to store topics inside of our database. If we go to our database for this section, we'll notice that we have the following tables. We have just the widgets table. Okay, so let's add another table so that we can relate these two, because topics have a one-to-many relationship with widgets, and we want to know how to render that, how to capture that fact. In a relational database, it's easy, right? Basically, you have the children have foreign keys pointing to the parent record, right? So how do we do that in Java? So in Java, the way you would do it is that you would have a class, and here you have topic, and in the topic, you would have your normal fields, right? Your private integer ID. And maybe a title for the topic. So this is title. Okay, and then to establish the one-to-many relationship between the parent topic and the children widgets, it's easy. In Java, you would just do it using some kind of collection. Right? You say that these are the widgets. There it is. Right? That's how you would implement it in Java. If this were Java, you're done. Right? Basically, you would have one topic containing many widgets, right? Then you can just iterate, navigate from the parent topic down to the widgets and just iterate over them and just render them. Yes? But because we know that we're going to have to map this to a relational database, we're going to have to do a couple more things. Right? In a relational database, the way we store things in a relational database is quite different the way we think about it in object-oriented technology. In object-oriented technology, usually the parents have references, pointers to their children using either an array or some collection like this, like list widgets. Yes? In a relational database, it's backwards. It is the children who have references to their parents. Right? The way we implement it in a relational database is that the children widgets would have a foreign key to the primary key of the topic. The topic would have no fields, the topic table would have no fields that at all reference the widgets. So the topics themselves have no knowledge that there are a whole bunch of widgets that are pointing or referencing that particular topic. Make sense? So the way you store this information in a relational database, it's the opposite on how you would store it in a object-oriented memory, stored in the memory of a CPU. So we need to bridge these two worlds, right? Also, in Java, typically the relationship is one way. You can navigate from the parent, you can iterate over the children, but typically from the children you have no way of getting back referencing the parent, right? Unless you have a variable in the children that actually points back to the parent. And you would do this if you have maybe a doubly linked list, or you have some data structure where you have where two nodes in the data structure point to each other. Yes? So that allows you to navigate down and up or left and right. But typically you wouldn't do that, right? You would have just parent-child relationship. Make sense? Now, in a relational database, it's the relationship between two records that are related through a foreign key, primary key, is by definition a two-way relationship, right? When you do a select star, from table A, comma B, where the A dot foreign key is equal to B dot primary key, right? When you do that, you can now choose from fields from both tables, from both records, right? Meaning that just that primary key, foreign key equal, right, allows you to access elements from both tables. So the relationship is two-way. You can navigate from the parent to the children, or from the children back to the parent, but not in Java. Yes. So sometimes these differences on how we store data in both of these worlds sometimes is referred to as the database impedance. There's an impedance. There's a barrier, right, that separates these two different worlds. So the way we're going to bridge this divide is we're going to use JPA. JPA. We're going to follow some of the standards, some of the best practices that the JPA helps us do this. And one of the first things that we're going to do to be able to support the fact that in relational database the direction is the relationship is two-way, we're going to go to the widget. We're going to go to the widget, again, only because we are establishing the relationship two-way, we're going to do the following. We're going to say private topic. Okay. Now in Java, now the relation is bidirectional. I can go from the topic down to the widget, and from the widget I can go back to the topic. Right? They're pointing to each other now. Okay. Obviously, you would have to implement all the setters and getters. So let's do that. Let's generate the setters and getters on both sides. Here. And then here, let's also generate the setters and getters. Okay. Oops, I didn't mean to do that. This is supposed to be way up here. Right here. All right. Excellent. So now we have the relationship bidirectional. The other thing that we need to do is that, to establish this as being two entities, two records that know about each other. Obviously, the topic needs to be converted into a table. We know how to do that. It's just an entity, NTT. We also might choose the name of the table using table name, and this is topics. We also, obviously, the default here is to declare here this is a primary key, and that this is a generated value with some strategy of identity. Oops, identity. There we go. All right. Okay, so that's boilerplate. How do we establish the relationship? How do we tell JPA that these guys, right, that this needs to be stored in the database using foreign key, primary key? Now, there's in Java, the way to implement it one-to-many is pretty standard. There's only really one way, right? The parent has some collection of the children. That's it. Okay. But in SQL, there's actually a couple of ways of doing it. One of the ways to do it is to have two records, right? And the way they relate to one another is that there's a separate table that maps the records, that says that this record over here is related to that record over there, right? Where this third table, the records in this third table has just pointers, has references, right? That says that, hey, that record over there is the child of that record over there. The other way to implement it is to have not this third table. Instead, you have one of the tables have a foreign key pointing to the parent, right? So we need to specify. We need to tell JPA, and tell JPA which strategy do we want to use. Right? The default strategy, if I don't do anything, the default strategy is to use this third table. Right? It'll create a table called topic widget, which will have foreign keys to point to both records. We're not going to do that. Instead, we're going to say, use the strategy where the widget, using the topic, I was going to use this as a foreign key, pointing back to me to the topic, right? So the widget is going to use the topic as a foreign key, pointing back to me in the topic over here. So the way we're going to do that is as follows. We're going to say that topic and widget are participating in a one-to-many relationship. Right, like this. You have the topics and the widget in a one-to-many relationship. And we have to specify which one is on the one side and which one is on the many side. Right, notice that this class over here is on the one side, and this other class is on the many side. Right, you have this. This is on the one side and this is on the many side. Right, so we need to tell each class which side are you on? So let's do that. We'll say here, you are on the one side of a one-to-many relationship, whereas the widget is on the many side of a one-to-many relationship. Right? You see that? So the widget, the topic is on the one-to-many side, and the widget is on the many-to-one. Okay, and this is how you label them. The next thing we need to tell JPA is that this topic is going to be used. This field is going to be used as the way of referencing as a foreign key back to me. And the way we do that is we're going to say that, hey, on the widget side there's a field called topic, there's a field called topic who's referencing me, right, as a foreign key, right? Okay, I think we're all set. The only thing left to do is that, notice that we already had a topic ID. See, it's there. See that? But that topic ID, that was when we were using we were storing topics in a remote database, right? My database, right? You're storing it in my server, in my database, yes? Right? So we're trying to replace that. We're trying to say, no, this is no longer stored in some other database. It's stored in the same database. It's stored in the same database. So I'm going to remove that topic ID. I'm going to remove that topic ID, and I'm going to remove the setters and getters that go along with it, right? Probably that's going to break something. If there were other classes that were referencing it, that's fine. Let's try it out, right? Other than that, let's see, what else do we need to do? Well, also because it had that topic ID, probably the tables that we played around last time around, it will have that topic ID, yes? Let's take a look at the database. Here's a widget table that we created last time, right? If we inspect it, we can send the create statement here. Notice that indeed the topic ID was varchar, right? We had declared as a string. But instead, we want this to be a foreign key integer pointing to a topic table that doesn't exist yet, right? The topic table doesn't exist yet, yes? All right. So JPA is going to try and convert this varchar into an integer and into a foreign key pointing to a topic table that is going to be created in a second, right? But it's going to fail. It's going to fail because when you try to convert a data type varchar into an integer, that means that the data might be truncated, right? So JPA is going to stop and not going to do it. It's going to leave it alone. It's not going to touch it. So we're going to have to just blow away our nice widget table. Just blow it away for now. Drop the table so that it could be recreated from scratch. We'll drop it. Okay, now let's try and convert this. Let's run this. Let's see if we forgot something. Looks like we did forget something. Let's see. Application, widget controller. Yeah, probably our widget controller was using that topic ID. Let's go to the controller. Let's see if we have something here. Widget, we're using that topic ID somewhere. Find widgets for topic is using, notice that this is a string. Passing that string in here. Doing a query on the widget, on the topic ID, and the topic ID now, this is supposed to be all integers now. Let's see, all this needs to change, right? Because now our topics are integers, not strings anymore. So let's remove this. Let's not implement that. That means that we're not going to implement that either. And our controller, we're not going to have that either. We'll re-implement it in a minute, but not using that. Where else do we have topics? I think that's the only one. Let's try that again. All right, excellent. So let's. Looks like it worked. Let's refresh our database, and let's see. We got now topics and widget now, right? We didn't have topics. Let's take a look at widgets, how it changed. Let's look at widgets, how it changed. If we send back the create command, notice what changed here. My new widgets table still has a topic ID, yes, but this time around it's an integer because the topic. Right, if we look at the topic table, and send the create statement, notice that the topic table, its ID is an integer. See that? Right, so my widgets table, the topic ID is referencing, notice that we have a constraint here that it says that topic ID, right? It's a foreign key It's a foreign key that references the topics table, the ID field here. See that? Right? That constraints is what allows us to now know that these topics are the parents of all these widgets. Before, all these topics exist in a different database, right? And the way we knew about it was that we were storing this ID for this remote record that lived elsewhere. But now, because they're living in the same database, now they're actually going to reference each other in the same database. Make sense? All right. All right. Excellent.